You are welcome once again to New Focus Approach to Mathematics Basic 7. This is the revised edition, and in this video we are going to learn how to express the magnitude of a vector from a column vector. This lesson can be found in page 315. Talk of magnitude, we are trying to find the length of a particular vector, the length or the magnitude of a vector. Now let's have this for illustration. We want to find the magnitude of the vector OA, which is given as 4, 3. That means 4 on the x-axis, 3 on the y-axis, and they'll meet at this particular point. So let's call the point A. Now, from the origin, where we have our O, we move the direction, or we move the vector from O to A. Now, we want to know the distance from the origin to the point A. And that distance is what is referred to as the magnitude of the vector. Right. Now, we can find this distance if we try to trace the point A to the x-axis so we can create right angle triangle. We know that when we have right angle triangle, we can find the hypotenuse by the help of Pythagoras theorem. Remember this Pythagoras theorem? Good. So the point is, let me do some labeling. Let's have point B here and have point C here, and say that, okay, with Pythagoras theorem, the distance B, or let me say the distance AB, or let me say AB squared should be equal to the distance BC squared plus AC squared. That is what we know from Pythagoras theorem. Now, what is the distance BC? The distance BC is from the point here to the point here, which is 4. So that will give us 4. Okay. So 4 squared plus the distance AC from the point here to that point here is 3. So 3 squared. Now 4 squared will give us 16. 3 squared will give us 9. We have our AB squared here. Now for us to find AB, we need to take the square root to both sides. And when we add this and this, we have, that is 25, right? And so our root of 25 will be 5. That makes the distance 5 centimeters. And so when we measure the distance from here to here, it's 5 centimeters. Now let's try to deduce something. Let us assume that I don't know the value, the distance between this and this, and I want to call it y. And I don't know the distance between this and this, I want to call it x. And I want to call this one r. Then we can say that r squared is equal to s squared plus y squared. Do you agree? So for us to make r the subject, we take the square root of s squared plus y squared. And this becomes a formula that we can use to always find the magnitude of a given vector. Okay, now let's look at this example. Find the magnitude of the following vectors. The first vector is 6, 8. So for me to know the magnitude, which is, let's say, the r, it should be equal to square root of the s component squared plus y component squared. And so when I substitute the component of 6 in place of x and that of 8 in place of y, then I can write this as 36 plus 64. That is 6 squared is 36 and 8 squared is 64. When I do the summation, I have 100. So all I need to do is to find the square root of 100. And since 100 is a perfect square, square root of 100 will give us 10. So the distance is going to be 10 units, because I don't know whether the distance is going to be in centimeters or meters or kilometers. So I can just write the word unit to represent the unit of the distance or the magnitude. I can do the same thing for this one too. Again, if I want to find the magnitude, I would say square root of s squared plus y squared. So what is root of x? That is negative 9 squared plus 12 squared. And this is going to be 81 plus 144. When you add 81 plus 144, So that will give us 225. And 225 is also a perfect square. And so since it's a perfect square, when you take perfect square, that is root of 225, the answer is 15. So we say 15 units. Right. So this is how we can solve magnitude of vectors. I'm sure you have more examples in the book. You can try your hand on them. Thanks so much for watching.